In this video, we're going to talk about exponential functions in tables. After this lesson, you will be able to identify exponential functions given a table and describe their rates of change. For each of the tables below, describe the rate of change, identify the type of function represented. That could be now linear, absolute value, quadratic, or exponential. If it's none of those four, you're going to say none, and explain why you picked the function you did. So step one for any table is always to do the change in y and change in x. Please do that for number one. So looking at my changes here, and I just want to point out when you're changing, you can check if it's correct. If it's 0 and you're going down your table, so 0 plus 1 is 1, 1 plus 1 is 2. I put those little arrows there to show you that you're using this change to go from 4 plus 1 is 5. And I can jump here, 14 plus 8 is 22. So that's what you're checking. So on every table, I'm going to see your change in x and your change in y. Hopefully right away, you can see your rate of change, which is the change in y over the change in x. And this is going to be 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1. Those are not constant. Those are not the same. So I know right away that this is not linear. If I look at what my, and it's not absolute value either, because absolute value would have constant. Absolute value just has two rates of change and they're opposites, a plus and a minus of the same thing. So I need to look at quadratics or exponential. And if I wanted to look at quadratics, and you don't have to write this down, you can just watch me because this is something you could do in your head. But I'm looking here and I know that 1 plus 1 is 2 and 2 plus 2 is 4 and 4 plus 2 is 8. I'm sorry, 4 plus 4 is 8. And so my table continues. And actually, you can notice here that if you have this kind of pattern, when you do the difference of your difference, again, if you do your second difference, I'm ending up with the same pattern just shifted down. So it's not quadratic either, which leaves us to check whether it is exponential. To check if it is exponential, you're looking at that, seeing if there's a common multiplier. Is there something that I can multiply or divide by? And because it's getting bigger, I know I'm looking for if something can multiply. And you might just see right away that 1 times 2 gives me 2, 2 times 2 gives me 4, and 4 times 2 gives me 8, 8 times 2 gives me 16. If you did not see that, you can go to a calculator. You should use a calculator, not your phone, because you can't use your phone on your test or the ACT. So you're always looking at the change in y's. And so you could take 2 and divide it by 1. So you can see, if you didn't know this and you're using your calculator, you could do 2 divided by 1, 4 divided by 2, 8 divided by 4, and this last one, 16 divided by, and I'm just hitting divided by. The way this calculator does it is it uses the division as a fraction bar. Oops, not 8. Not 2, it is going to be 8. And you can see that that's 2. So all of the ratios between the changes are 2. So this times 2 is showing me that my rate of change is increasing by a factor of 2. So it's my changes. These changes are increasing at an increasing rate. They're getting faster and faster. That's why it's going up quickly. And it's increasing by a factor of 2. That's this times 2 right here. And we know that that means that it's exponential. And for y, you could put a couple of things. You see that you have times 2, and you can see that it is increasing quickly. You could also say no turning point, but you really, for it to be exponential, you have to have this, increasing by a factor or decreasing by a factor. Looking at question 2, please find the change in x and the change in y. So looking at these values, I see that my change in X is increasing by 1, which means to look at rate of change, I'm really just looking at my change in Y, because negative 186 over 1, negative 162 over 1, those are all just the same as these Y values, or change in Y values. And we can see here that this is not a constant rate of change. So that rules out both linear and absolute value, because they both have to have straight constant rate of change. Absolute value would have 2 because it has opposites, but neither are the case here. So we can look at our second differences or our second multipliers, and we check second differences first. And you can see pretty quickly here that there is not a constant second difference, because this difference right here from negative 18 to negative 8, if I look at my number line, negative 18 would be just off here, but to negative 6, this is just this little amount. But if I had to go from 54 to 18, or negative 54 to negative 18, that would be much bigger, and even bigger between negative 486 and 162 if I found those differences. So I know now that I'm looking at a multiplier. And I'm looking here at my values here, and I know I'm decreasing. So I'm going to start, and I'm just going to write that we know that this is decreasing, and we're going to figure out what it's decreasing by. And so you're going to want to pull out your calculator to divide this. You might recognize down here, I look at these smaller numbers because those are numbers that I know in my head. So I can look at negative 18 and negative 6 and think, oh, 6 times 3 gives me 18, or 18 divided by 3 gives me 6. And that's this true also for negative 18 divided by 3. So negative 18 divided by 3 gives me negative 6. So, but if you didn't see that, you could still be dividing on your calculator. And so I'm going to pull up a calculator now. When I'm using my calculator, I usually just take the bigger number. So I'm going to take my 486 and divide by 162. Oops, I missed 162. And hit enter. That says it's 3. So 486 times 3 is obviously going to be bigger. It's not that. So that's how we know that this is going to be divided by 3. If I divide it the other way, so if I take 162 and divide it by 486, I get 0.3 repeating. So I could also, 0.3 repeating is 1/3. So that's just the reciprocal of 3, and that's why, multiplying by 1/3 is the same as dividing by 3. And you can see I put these other two differences in my calculator and divided those ratios to see that they are also changing by a factor of 3. And these are dividing by 3. As you can see, where our graph is getting smaller, or our table is getting smaller and smaller and smaller. And so we are decreasing by a factor of 3. So whenever we're decreasing, we see that should be the division symbol. Whenever we're increasing, that's going to be the multiplying symbol when we're talking about factors, which is another way of saying multiplier. So of course, this is exponential. And it's because we see that we are dividing by 3 for that change in y, and we are decreasing quickly. For this last example of the video, I want you to find the change in x and change in y. You can see here that our change in x's are increasing by 1, again on a number line. Negative 5 to negative 6 is an increase, negative 6 to negative 5 is an increase of 1. And you're moving to the right as you go down this list. That's why these are increasing. 48 to 32 would be going to the left on the number line. See it easier when you're thinking of 16 to 0. 16 would be right here. 0 would be here to the left. So these are decreasing. They're decreasing by the same amount. What does this tell us? Negative 16 over 1 for our rate of change. Each of these is negative 16 over 1. That tells us that we have a constant rate of change. And that constant rate of change is negative 16 over 1. Anytime we have a constant rate of change, that tells us we have a linear function. And that's just because we have a constant rate of change. Other characteristics is that it's only decreasing, and it's decreasing by the same amount. To quickly summarize our 4 types of functions and how you see it in the table, we only had exponential and linear in these examples, but the rest of your examples could have any of them. Linear is only going to have a constant rate of change. That means in your table, you're only seeing increasing or decreasing. Absolute value has a turning point, and it's also going to have a constant rate of change, but there's going to be 2. They're going to be opposites. Quadratic functions also have a turning point, and you are looking at the second differences. So you're not seeing constant when you're looking here at your change in y's. You have to look at the second difference and see that your second difference is constant. Exponential functions, again, no turning point. It's only increasing or decreasing, and that increasing or decreasing is increasing or decreasing by a common multiplier, and that's what you see right here on these 2 types of problems.